Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad bin Ahmad KHAIRI. Metric number is DE220154. I'm from Group 7, Session 1. So, first I will introduce my eldest group member. Is Muhammad FIRDAUS bin Muhammad SUKI, DE220088, and last Muhammad Amin bin Agus, DE220109. So first, I will explain about the uh, calculation part for the Fourier series. So, first of all, we state the value of voltage supply in AC and DC element. So, the general form, of VT is VT is equal to A naught plus summation AN cos n omega naught T plus Dn n omega naught T. So for the we should find three element, which is A naught, and we use the formula is 1 over T integration from 0 to T ft dt. So we get the answer 0. And An, we use the formula 2 over T integration from 0 to T ft cos n omega naught T. So the answer is also 0. And for the value of Bn, we use the formula 2 over T from 0 to T ft sin n omega naught T dt. So we get the answer is 10 multiplied with 1 negative n, negative 1, the power of n over n pi, which is n equal to 135. So we get the value of the voltage supply, which will be in T domain is 220 over n pi. The angle is negative 90. So after we get the value of voltage supply, we translate into the circuit. So we use the circuit in series, RLC and RLC in series. So we know that when the circuit is series, the equivalent current is total in equal to total current out. So we should find a current in 3 harmonic. So for the first harmonic, for to find the current, we use Ohm's law, which is V over Z. So the Z is equal to negative 7 times to pi n square plus 125 plus multiply to times to imaginary omega n pi n plus 5 over pi n j. So the first harmonic of current is value 5.09 times to 10 power of negative 3, and the angle is 0.9. And for the third harmonic, we get the answer 1.6 times to 10 power of negative 3, the angle is 0.6. And the fifth harmonic, we get the answer 7.65 times to 10 power of negative 3, and the angle is negative 2.75. So after we get the voltage and current, we should find the voltage drop in each element. So which is VC, VL, VR. So in voltage drop at capacitor, we use the formula, we apply the voltage divider rule. So for the voltage drop harmonic 1, we get the answer 0.08 angle, or the angle is 2.5 volt. And the third harmonic, we get the answer 7.97 times to 10 negative 3, the angle is 2.19. And the fifth harmonic, we get the answer 2.4 times to 10 power of negative 3, the angle is 1.9 volt. So the equivalent equation of the voltage drop at capacitor, this is the voltage equivalent equation. So I will pass the presentation of the calculation part of the for the series to the our group member. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FIRDAUS bin Muhammad SUKI. Matrix number DE220088. So in this video, I will present about how to calculate voltage drop at inductor. So first, we need to convert the value of inductor from 7 Henry to 7S. So we will be for S, we assume that J pi n. So for equation to find the voltage drop at inductor, uh, in value of inductor over total impedance times dengan with V in. So we just put the value of inductor and total impedance. So for total impedance, we have find before this here. So just put the value, and for V in, we find at here for V in. So for N1, we just put a value, and we will get value for 1.1054, negative 9.2688. So for N3, we will get answer 2.977, negative 27.63. So for harmonic 5, we will get the answer 4.21, negative 41.254. So next is voltage drop at resistor, same as inductor for formula. So the resistor we will get 1250. So we just put the value in formula, and we will get the answer. So for harmonic 1, we will get 6.283, negative 2.197. For N3, 1.878, negative 2.5178. For harmonic 5, 0.9572, negative 2.755. So for lastly, if power average, so formula for power average, which is Vn times In over 2 times cos for theta voltage minus theta current. So we just put the value in formula. So we will get the answer for harmonic 1, which is 1.612 times 10 power of negative 3. Harmonic 3, 0.179 times 10 power of negative 3. For lastly, 3.665 times 10 power of negative 3. So for total power average, we'll plus all the answer for harmonic 1, 2, 1, 3, and 5. So we will get the total 5.456 times 10 power of negative 3. I think that's all from me. Thank you.
Assalamualaikum, my name is Mohamad Amin, and I will present about our simulation circuit in multisim. So as you guys can see, this is our circuit, and we use 7 Henry indicator, 0.2 farad capacitor in series, and 125 ohm resistor in series, and one ground. So this is our circuit, and in the function generator, we set the waveform to square, and our frequency is 500 millihertz, and duty cycle is 50%, and amplitude is 5 Vp. And lastly, we attach the power probe on the resistor to measure the power average. After we settle the circuit, we can run the simulation, and we can see the power average is around 286 milliwatt. On the waveform on the oscilloscope, to get the waveform, we need to double click on the oscilloscope and set the time base to 1 as per diff, and to get the exact waveform on the manual calculation. Next, to get the Fourier analysis, we need to click the interactive and set to the active, which is active analysis. We click the Fourier, click the analysis parameter, and our sampling option is frequency resolution is 0.5 Hz, and number of harmony is 5, and start time for sampling is 1.8. And next we set to the output, and to the value that we need, and this is our output, and we set to the IR1, which is our circuit I total, V1 for the voltage on the resistor, V2 for the voltage on the inductor, and V4 is voltage for the capacitor. And lastly, save and run the simulator to get result. So on the report, we already attached our result simulation. So this is our result on the simulation multisim. Okay. And on the discussion part, this is our comparison of our manual calculation and the simulation. So I think that's all from me. Thank you very much.